In this video I'll be showing you guys how to draw free body diagrams. So what are free body diagrams? Free body diagrams show or display the magnitude and direction of forces acting on an object. They're super important whether or not you're in high school physics or you're an engineer designing a bridge. You always need to display the forces acting on whatever you're working on in a clear way, so that when you do your calculations you can refer to it and make sure you account for every force in the problem. So in this video I'm going to show you just the basics of free body diagrams. If you know enough already, then you can go watch other videos I'll be making about more in-depth problems and stuff. But I'll start off by showing you guys, or writing down the steps I go through when I draw a free body diagram. So a free body diagram is usually either a point or a box. And this box or point has arrows pointing away from it to show the forces acting on the object. So I typically use a box because I find it, when you have a lot of forces, it's a lot easier to see where they're acting, and it gets a little messy with a point, but it's all preference. So the first step in drawing a free body diagram is reading the problem carefully. This is important because a lot of times it's hard to know all the forces acting on an object, so you need to make sure you're incorporating all the forces if you're going to be doing the problem correctly. So once you've read the problem, you check and see what all the forces are and their magnitudes and directions. So you determine magnitude and directions of forces, as I said before. Once you have these and you know all of them, you've read the problem well enough, you can draw the box or point. So I draw a box, and I think you guys should too. Once you draw the box, you draw each force as an arrow with the tip pointing in the direction of the force. So as you can see up here, I did that. You also have to write down what forces these arrows represent. So let's say this is a normal force and this is force due to gravity. And in addition, if you're solving problems, you need to write down what your axes are and what your positive axes are. So this would be positive y, this would be positive x. So now I'll go through a quick example. It'll be pretty simple, and I'll do more in-depth examples later on, but this is just to give you an idea of how you would use a free body diagram. So imagine an apple sitting on a desk. this apple which has a mass of 1 kilogram. So, and then you're also asked what the reaction force produced by the table. So whenever you do these kind of problems, you always start out by reading it well and then going through the steps and drawing a free body diagram. So right now you have an apple sitting on a desk, right? And it looks like a cherry, but I just got this new tablet, so I'm not very good at it yet. But okay, so this is the apple. It has a mass of 1 kilogram, so it'll have a force due to gravity acting downwards. This is not the free body diagram, by the way. I'm just showing you the forces. And there's also going to be a normal force acting upwards from the table. As the apple weighs down, the table pushes back upwards, which is Newton's third law of motion, where for every action there's an equal and opposite reaction. So when you're drawing the free body diagram of this, you draw a nice little square, and we'll write A on it for apple. So you have the force due to gravity, right? So you draw an arrow downwards, and this is FG. You have an arrow upwards, and this is N, or the normal force. And you know FG is equal to the normal force because the apple's not going anywhere. But in solving this problem, you know that the forces in the y direction are equal to 0. It's a statics problem. And as I said before, you need to have your axes, right? You need your positive y, your positive x. So you have the normal force going upwards, so it's positive, minus the negative force due to gravity is equal to 0. You know the force due to gravity is going to be equal to 1 kilogram times 9.8 meters per second squared. This is mg, which is equal to 9.8 newtons of force downwards. So when you solve this problem, you add Fg to the other side, so N is equal to Fg, which is 9.8 newtons. Obviously the statics problem is really easy, but the idea is more to make sure you're drawing a nice, clear free body diagram that shows the forces acting on the body. In future videos I'll do free body diagrams with beams, with moments and stuff like that, so that it won't be as simple as this, but it's good to get a basic idea of how free body diagrams work.